If you've been watching Marvel movies, you've probably noticed that the reactor in Tony Stark's chest keeps changing. At first, it's just this simple round thing, and later on, it starts looking way cooler like this. But the most important change actually happens in Iron Man 2, because that time, it's not just the shape that changes.
It tastes like coconut. Metal. Oh, wow, yeah!
Yeah, in Iron Man 2, Tony Stark starts getting poisoned by palladium, the element powering his old reactor. And that's when he ends up creating an entirely new element to replace it. That moment when Tony creates a new element is what we're talking about in this video, because it turns out this idea connects to what real scientists actually do. Smashing atoms, building massive machines, and even discovering something people call the God particle.
It is news that has the science community buzzing. The discovery of the Higgs boson, the so-called God particle.
It is being hailed as one of the greatest scientific discoveries of our time.
The scientists following reports that the elusive God particle has been found.
They say they have found the Higgs boson, the so-called God particle. It's a theory scientists have been chasing for decades, a subatomic particle believed to play a critical role in the creation of everything in the universe.
So how do we make new elements in the real world? Is it really done by blasting them with lasers like Tony Stark? Well, you'll find out the answer if you subscribe to this channel. Nah, just kidding. All of those questions, we're breaking them down in this video. So get your brain ready, because we're going back to high school science mode. All right, let's talk about it. Alright guys, let's start with a scene most of you have probably never seen. This is a deleted scene from Iron Man 2. In this scene, Tony Stark is trying to figure out a new atomic structure to create an element that can replace palladium, and he does it using the periodic table. Yeah, the periodic table. You still remember this thing, right? Basically, it's a list of all the elements in the universe. And if you look closely, every box has these weird numbers on it. What are those numbers? Relax, we'll get to that in a bit. Because the real point of the periodic table isn't memorizing it. What actually matters is understanding what it's used for. The main function of the periodic table is to decide what materials we use to build technology. From the smartphone in your hand, the car you drive every day, nuclear bombs, all the way to Iron Man's suit. And by the way, quick fun fact, Iron Man is just a name. The suit itself isn't actually made of iron. It's made from materials like gold and titanium.
Iron Man, that's kind of catchy. It's got a nice ring to it. I mean, it's not technically accurate. The suit's a gold titanium alloy.
Because if it were really iron, Iron Man would have been rusty as hell. Now let's go back to Tony Stark standing in front of the periodic table. In that scene, he had already tried 486 different element combinations to replace palladium. None of them worked. Until he tried the very last combination, cerium and dysprosium. These weren't random elements. On paper, this combo actually made the most sense to replace palladium. But the result? Same thing. Another failure. At that point, Tony Stark was completely stuck. Not because he wasn't smart, but because every possible combination within the periodic table had already been tried, and none of them could replace palladium. And that's when he realizes something important. The problem isn't the combination, the problem is the element itself. Because no matter how you mix them, all those elements still come from the same periodic table. And that's when Tony Stark finally finds the clue left behind by his father. Not a clue about how to mix elements, but about how to create an entirely new one. Hold on, can we actually create new elements in the real world? The answer is, yeah, we can. And this is something scientists have genuinely done in the real world.
Scientists created the first artificial elements during World War II, and they were actually classified at first. And it was only afterward that they were allowed to announce the discovery of these new elements.
Take a look at these elements that are circled here. If you count them, there are 28 of them. And none of these are naturally occurring elements. They're synthetic elements, created by scientists in laboratories. Now, if you look a little closer, you'll notice something else. Every element has those weird numbers on it that we mentioned earlier. For example, gold has the number 79 on top. That number tells you how many protons are inside the nucleus of a gold atom. Because like we learned in high school, inside every atom, there are three main particles: protons, which are positively charged, neutrons, which are neutral, and electrons, which are negatively charged. The protons and neutrons sit in the nucleus, and the electrons move around it. And here's the key part. The number of protons in the nucleus is what defines the element. If an atom has 79 protons, we can say it's gold. Or if it has 47 protons, it will be a silver. And that proton number is really where Tony Stark's problem starts. No matter how many combinations he tried, they were all bound to fail. And that makes sense, because from the start, what Tony was doing was just creating alloys, not the new one. You can mix materials in any way you want, but as long as the number of protons in each atom stays the same, the element itself doesn't change. Luckily, Tony eventually notices the clue hidden in the map, and that's what gives him a direction on how to create a new element. In the story, Tony creates this new element by firing a beam at an existing material using a machine he built himself, basically wrecking his own house like this. In theory, what Tony Stark is doing by firing a beam at an element like this is actually a way to change its atomic structure. But in the movie, the machine that he used to create the new element looks like this, and in the real world, the machines look more like this and this. These machines are called cyclotrons and the Large Hadron Collider. Let's break down the cyclotron first. In theory, creating a new element sounds pretty simple. You just need to add more protons into an atom's nucleus. But here's the problem, guys. The protons don't just stick to the nucleus that easily. Why? Because protons are positively charged, and the nucleus is already full of positive protons. And like we all know, same charges will repel each other, just like when you try to stick two magnets together with the same poles. So the only way to add more protons into the atomic nucleus is by forcing it using a massive amount of energy. And that's exactly why scientists built a machine called a cyclotron.
So we use what's called a particle accelerator, or specifically a cyclotron, which is a large instrument that accelerates ions to a fraction of the speed of light.
Inside a cyclotron, protons are spun around using magnetic fields, faster and faster, until they're moving close to the speed of light. The whole point of this is to give the proton enough energy to overcome that repulsive force inside the nucleus. Once the energy is high enough, the proton gets fired at a target atom. If it successfully sticks, the number of protons in the nucleus changes, and that's when a new element is created. If it doesn't work, well, they just try again.
And then very, very rarely, we'll get this head-on collision that makes that atom that we want.
Right inside this box, that's where our elements are made.
But we need to understand that in the real world, all of this process happens entirely inside the cyclotron machine. There are no beams shooting across the room like this. You know how it is, guys. It's a movie. Without all the glowing stuff, it wouldn't look cool. And unfortunately, in the Iron Man story, Tony never tells us what the new element actually is, or how many protons it has. Even that periodic table scene was deleted, probably because it's fiction, and there's no way it could jump ahead of real-world experiments like that. And if you look at the shape of Tony Stark's machine, a long, weird pipe like this, it actually doesn't feel unfamiliar at all. Because in the real world, besides the cyclotron, there's another machine that scientists use to smash particles together. And it's also a long pipe machine, just like Tony's. But the difference is the scale. Tony Stark's machine is basically just room-sized. In the real world, it's 27 kilometers long. This machine is called the Large Hadron Collider, or LHC. And this thing is on a completely different level compared to a cyclotron or Tony Stark setup. Because in the LHC, scientists aren't smashing particles into atoms, they're smashing particles into other particles. And the goal isn't to create new elements. The goal is to break open the most fundamental ideas about how the universe itself formed. Basically, it's like the physics behind the Big Bang. That's why the LHC is sometimes called a Big Bang machine. Inside the LHC, protons are accelerated to almost the speed of light, then slammed directly into other protons coming from the opposite direction. And from these insanely energetic collisions, scientists can observe particles that normally never appear in nature at all. And it's through this machine that scientists eventually discovered what we call the God particle. So if the cyclotron and Tony Stark's machine is focused on the atomic nucleus, the Large Hadron Collider is focused on the very foundation of reality itself. We'll talk more about the Big Bang and the God particle in another video, because those topics are heavy on their own. What matters from this video is that we now understand what Tony Stark does in his workshop isn't pure fiction. We can actually do the same thing in the real world, of course, with a different method. And maybe more importantly, It shows that humans always find ways to push past their own limits.